Theorem 8. A tangent to a circle is perpendicular to the radius drawn to the point of contact. The point of contact is the point where the tangent and the circle meet. On this diagram, our point of contact is point B. That is the point where the line AC, which is our tangent, and the circle meets. The theorem says at this point, the radius meets the tangent at 90 degrees. That is, the angle between line OB and line BC is 90 degrees. And the angle between line OB and line BA is also 90 degrees. So that is our theorem 8. Theorem 9. Two tangents drawn from an external point to a circle are of the same length. Two tangents from the diagram here are PQ and RQ. They are all from the point Q. The theorem says the distance between PQ and RQ are equal. That is, RQ here is equal to PQ. That is what the theorem says. And so we can draw something like this, a straight line from P to O, line PO, and from the theorem 8, the angle here at P will be 90 degrees. We can equally do it here and then get an angle 90 degrees at R. Now, OR is equal to OP. Remember, they are both radius. So they are both radii. And so when you look at the diagram quadrilateral ROPQ, we get a kite with a line of symmetry through O to Q. So that is our theorem 9. Example 1. Find the values of the angles labeled X and Y, with TU being the tangents to the circle with center O. Okay, our task is to find the value of the angle X here and the angle Y here. Now, when you look at the diagram, you see the line OQ and the line OS to be equal. That is, both are radii. That shows that our triangle QOS is either isosceles or equilateral. But for now, we only know the two sides. So let's say it is isosceles. That means that the base angles here and here are equal. So let's label them A. So each one is the same of the same size. So we use the same variable for them. Good. Now let's find the value of A using the idea that angles in a triangle sum up to 180 degrees. So A plus 60 degrees is equal to 180 degrees. 2A will be equal to 180 degrees minus 60 degrees. So our A will be equal to 120 degrees divided by 2. Our A is equal to 80. Our A is equal to 60 degrees. We continue. Line QR is a diameter, which means it is subtending an angle at the circumference point S, which will be 90 degrees according to theorem 2. So our angle QSR is 90 degrees. And then our angle RQS is 60 degrees. Okay, so still with angles in a triangle, we will have 60 degrees here plus this 90 degrees here plus x equal to 180. So we have x plus 60 degrees plus 90 degrees equal to 180 degrees. Our x will be 180 degrees minus 150 degrees. So our x is equal to 30 degrees. Okay, now OR is a radius and TU is a tangent. The theorem 8 says these two meet at 90 degrees. That means x degrees plus y degrees is equal to 90 degrees. We know x to be 60 degrees. Sorry, we know x to be 30 degrees. So our y will be 90 degrees minus x. And so y is equal to 90 degrees minus 30 degrees. Our angle y is 60 degrees. That is it. It's very simple. Example 2. Find the values of the angles labeled x and q. Angle x here, angle q here. Now let's look at the diagram. We can see that line AB is a diameter and AB is subtending an angle at C. And if you remember theorem 2, this angle will be 90 degrees. With that, we can say x plus 90 degrees plus 33 degrees is equal to 180 degrees. Angles in a triangle. So our x will be equal to 180 degrees minus 123 degrees. Therefore, our x is equal to 57 degrees. Let's look at the second reference we can make. We have line D being a tangent. We have line BC being a chord meeting the tangent. So the angle between a chord and a tangent should be equal to the angle within the alternate segment, and that angle is subtended by the same chord. So the same chord BC subtending an angle at A. That angle is angle X. And so we have S degrees being equal to Q degrees. We know X to be 57, therefore our Q is equal to 57. If I want to add a degree, Q degrees is equal to 57 degrees. Example 3. In the diagram, line VX is a tangent to the circle UYW at W. If WY is parallel to UV, angle UYW, angle UYW is 95 degrees and angle UWY is 46 degrees. We have to find angle UVW, the angle here. Okay. Now let's look carefully at the diagram. We have tangent VX meeting the chord UW. Now the angle between the tangent and the chord in this segment should be equal to the angle subtended by the same chord in the alternate segment. So we have the chord UW subtending an angle in the alternate segment, and that angle is angle 95 degrees. And so we will say the angle UWV is 95 degrees. That is according to theorem 7. Then we can see that line UV and line YW are parallel. So let's do an extension of the lines. Do you remember? If you see this, do you remember? So we have our U here, we have our W here. What do you think of alternate angles? This. So our angle VUW, this angle, is equal to angle UWY, this angle. And so this angle VUW is 46 degrees. I hope you agree with me. So here 46 degrees. With that, we can say that 46 degrees plus 95 degrees plus angle UVW, which we are looking for, is equal to 180 degrees. So our angle UVW is equal to 180 degrees minus 141 degrees. And so that angle UVW is equal to 39 degrees. Example 4. In the diagram, O is the center of the circle. OM is parallel to XZ, and angle ZOM is 25 degrees. We have to calculate angle XYZ. OM is parallel to XZ, and then angle ZOM is 25 degrees. We have to find angle XYZ. Okay. Now let's do an extension of the parallel lines. We see that this angle is alternates this angle, and so we have 25 degrees here. Also, let's draw a line XO. You see that we have XO and ZO being equal. So the base of this triangle ZOX are equal. These angles are equal. So here will be 25 degrees. Now, angle ZOX is equal to 180 degrees minus 25 degrees minus 25 degrees. And so the angle ZOX is equal to 130 degrees. Now let's clean it and then make another reference. We are making reference to theorem 1. We have 130 degrees here. Now, chord XZ is subtending an angle at the center. The same chord XZ is subtending an angle at the circumference. Do you remember theorem 1? Good. That means 2 times angle XYZ is equal to angle XOZ. That means our angle XYZ is equal to 130 degrees divided by 2. So our angle XYZ is equal to 65 degrees.